Hi everyone. So I wanted to make this video as a study guide for your Unit 1 exam. So I'm going to go through questions that are very similar to the ones that you're going to see on the exam. So the best thing to do would be to grab some paper and pencil right now and just go through these problems with me. Feel free to make any notes you want. You can write down these problems as we go. That way you'll have a really good page or pages of notes when you go through your unit exam. So the first several questions talking about which of these represents a function. So there's lots of different ways they can show you pictures. So this one's like more of a visual picture. There's tables, there's graphs. So we're going to go through each of these. So remember, a function means for each input, there is exactly one output. So if I look at this first picture right here, here's my x values, my input, here's my output. This one is not a function because if you notice this one dot right here, whatever number this is, it did not have an output. And to be a function, every input has exactly one output. So this one is not a function. So move over to this one. We have this number going to here, this number also going to here, this one going to here, and this one going to here. This is a function. It's okay for two numbers to go to the same output because each input still has just one output. It's okay if they're the same output, but they have to have just one output. So this one is a function. We go over to this example. We see this first number going to two separate dots. And then this one's just going to one dot. This one's going to two separate dots. And this one's going to just one. So this is not a function because each input does not have exactly one output. This input has two outputs, and that's not okay. So that one's not a function. So things that aren't a function, if we have one number going to two different outputs, that's not okay. We also, if we have a number that's going to no outputs, that's not okay either. Okay, now looking at a table. So this is the same. We have our inputs and our outputs, but now we're just looking at numbers instead of pictures with arrows. So looking at these inputs, I have 0, 1, 2, and 3, and they all have an output. So this one seems like, yes, that's great. That's a function. Here I have 0, 1, 2, and 0. So here I have 0 with an output of 3, and this one I have 0 with an output of 6. So that's similar to this picture up here where we have one number, 0, having two different outputs, and that is not okay, so this is not a function. If I move on to the next table, I have 0, 1, 2, and 3, and they are all going to the same output of 0, but that's okay. That's like this, where one or two different numbers or more numbers are going to the same output. That's okay. As long as each number has an output, has one output, then that works. So this is a yes. This is a function. Here, this one, my inputs are 0, 1, 0, and 1. And I have 0 going with an output of 7, and then I have 0 with an output of 11. So just like this one up here again, we can't have one number having two different outputs, so that's not a function. If we want to look at these in graph form, sometimes we use something called the pencil test or the vertical line test. If you take your pencil and move it along this graph, it should never touch the graph in two different spots. So this is a function. This one's fine. Here again, if I move it along, yep, that's a function. There's no spot where my pencil touched the graph in two different places at the same time. So I'll show you what I mean here. On this one, if you look at my pencil's actually touching three different spots on this graph at the same time. So I'm just going to pretend, say this is the number 1 right here. 1 on this graph has three different outputs. So if my input was 1, I wouldn't know what to say my output was because I have three different outputs all for that same x value. So this one is not a function. It did not pass that vertical line test. This is a little tricky right here. It almost looks like this one wouldn't pass the vertical line test. Like maybe this is the number -1 right here. It looks like -1 might have two different outputs, but see this open circle. An open circle means I am not including that in my line, everything bigger than that -1. So this one is a function because they had that open circle there. So there was only one output for this number, -1. The next things that you're going to get asked on your exam are about domain and range. So I want to make sure that you have good definitions written down for domain and range. If you need to, you can go back into the lesson and find where they talked about domain and range. But domain is your input values, or like your X values. And range is your output values, or your Y values. They call them all sorts of different things, but the domain is what you put in, and the range is what you get out. They're going to ask you different questions about these, so make sure you have something good written down for these, for your definitions, so that you can answer those questions the best that you can. Okay, moving on. So function notation, so like this, f of 10, that's how you say that, by the way. F of 10 equals 9. Which function is represented? So if they gave you this multiple choice, which of these works for f of 10 equals 9? So well, I'm going to have to plug in 10 and see if this works. So if I do it for the first one, f of 10 would equal, that means I'm putting in 10 every time I see an x. So 10 squared plus 1. So I would have that f of 10 equals 100 plus 1. So I can already tell that 101 is not the same as 9. So this one does not work. If I go down here and I try to plug in that 10, f of 10 equals, I would replace this x with a 10. So 10 minus 2. So f of 10 equals 8. Nope, I need f of 10 to equal 9. So I'm going to try this last one. F of 10 equals, again, I'm replacing this x with 10. 10 minus 1. So f of 10 equals 9. Yay, that's what I wanted, f of 10 to equal 9. So this would be the function that was represented by the given information. So they might also ask you the same thing on a graph. So what is f of x when x equals 1? So on this graph, I want to find where x equals 1. Now remember, on a coordinate plane, this is your x-axis, the horizontal axis, and this is your y-axis. So when x equals 1, I'm going to find 1 on my coordinate plane, and I'm going to see which output value I had for 1. So I'm going to find that dot on the graph, and this one is -1. So I would say f of x equals -1, or you could write f of 1 equals -1, because they were asking what the value was when x equals 1. Okay, in a table, write a function to represent this table. So they give you some input values and some output values. So you are going to have to figure out what is happening in this table. When I put in -10, I got out -5. I put in -8, I got out -4. I put in 6, I got out 3. I put in 12, I got out 6. So hopefully you're starting to see a pattern of what is happening to those x values. So they want you to write a function, which means we're going to be writing it in function notation. So I would say f of x equals, and to me it looks like I'm dividing them by 2 or multiplying them by 1/2, whichever way you want to write that. So I would write f of x equals x divided by 2. You could also have written that, if you prefer fractions, f of x equals 1/2 of x, because dividing by 2 is the same as multiplying by 1/2. So either of these answers would represent this table, and you can always test your answer too. So just grab one of these x's, grab 6, plug it in and see if that works. 6 divided by 2 is 3. Yep, that was my output value. All right, moving on. Number 9. So Dave rents a car for the week. It costs $30 plus 25 cents per mile. Write a model to represent this problem. So I'm just going to use f of x notation. They might ask you to use different variables. So I know that the car is going to cost $30 for sure. So I'm going to write 30 plus it costs 25 cents every mile. So I'm going to write 0.25. And now I'm going to use that variable x to represent my miles. So if it was 10 miles, I would have to do 25 cents times 10 and get $2.50 plus the $30. It's always going to cost $30 plus however many miles you drove. So that would be my model. And knowing if this is linear or exponential, they will ask you this on the exam. A linear model has just a variable like this. An exponential model would have a variable with an exponent, like x to the second power, or x to the third power, or x to the fourth power. So this model is linear because there are not any exponents. All right, next page. What is an example of an arithmetic sequence? So you learned about sequences. This one sounds like arithmetic, right? Arithmetic. So that means you're going to be adding the same number every time. So you can come up with your own example. Let's say I want to start with 5 and I'm going to add 2 every time. So my arithmetic sequence would be 5, 7, 9, 11, 13, and so on, because I was adding the same number every time. I added 2 every time. So that's an example of an arithmetic sequence. Next one. This is where I think it gets a little bit trickier. So they're going to give you a recursive formula, which means that they are giving you one answer and then something based on that previous answer. It's a little bit tricky. So let's walk through it. So if they tell you that f of 1 equals 3, and then they tell you this, f of n plus 1 equals 2 times f of n minus 1, well, that seems really tricky. I'm going to have to grab my power cord really quick so that this video doesn't run out. So hang tight for 1 second. All right, sorry about that, you guys. So what I'm going to do is, because I know f of 1, I'm going to make f of n 1. So here's what I'm going to do. I'm going to replace this f of n with f of 1. So I made n 1. So over here, I also have to make n 1. So if I have 1 plus 1, that's going to be f of 2 right there. And I'm going to leave everything else the same. I'm going to show you what to do here. So now what this is going to end up telling us is what f of 2 equals, which will be useful for us. So it's going to be 2 times f of 1. Well, they told us up here that f of 1 equals 3. So I'm going to replace f of 1 with 3 and leave everything else the same. So I'm figuring out what f of 2 equals. Remember your order of operations, I need to multiply before I subtract. So 2 times 3 is 6. 6 minus 1 is 5. So I now know that f of 2 equals 5. The question is asking, what is f of 5? Well, I'm going to have to keep going on this recursive formula to figure that out. I now know f of 2. So using that, I can figure out f of 3. So I'm going to use the same formula again, except I'm going to figure out f of 3 this time. And I'm going to plug in f of 2 in here. So 2 times f of 2 minus 1. So I'm going to just solve this the same way I did the other one. I know that f of 2 equals 5. And I know that I'm going to multiply before I subtract. So 10 minus 1 is 9. So I know f of 1 is 3, f of 2 is 5, f of 3 is 9. And I'm going to keep going. So I'm going to use the same formula, and I'm going to figure out f of 4. So I'm going to go 2 times f of 3 minus 1. So I can plug in f of 3, which we know was 9 from this previous problem. So 2 times 9 is 18, minus 1 is 17. Okay, I'm almost there. Now I can figure out f of 5. So f of 5, using the same formula, is 2 times f of 4 minus 1. So f of 5 equals 2 times, we know f of 4 was 17, minus 1. So f of 5 is going to equal 2 times 17 is 34. 34 minus 1 is 33. So there is my answer. That's a very difficult problem using that recursive formula. That's kind of tricky. So the reason I like making these videos is you can go back and watch me do that again as many times as you want. Also, just write these down. and then you'll have great notes to use when you get to your exam. All right, number 12, very similar. What is the sixth term in this sequence? So now they're writing it in kind of like a sequence notation instead of this function notation, but very similar. It has like a recursive property to it here. They told you that a of 1 equals 9, and we're looking for a, and they give you a of n equals a of n minus 1 minus 6. So we're going to do the same sort of thing, and we're looking for the sixth term in this one. So if I know a of 1, I'm going to plug that in and do the exact same thing that I did up here. So let's try plugging that in. So I want to now try to find a of 2, because I already know a of 1. I'm going to try to find a of 2. So I'm making n into 2, which means that 2 minus 1, this is where I'm going to put a of 1. So equals a of 1 minus 6. So a of 2 is going to equal 9 minus 6. So a of 2 is going to equal 3. I want to find the sixth term. So I'm going to keep going here. I'm going to say that a of 3 equals a of 2 minus 6. So a of 3 is going to equal 3 minus 6. So a of 3 is going to equal negative 3. And I can just keep going until I get to a of 6. So you don't need to watch me do the whole thing, but just keep going using that same formula. All right, next one. So now they're going to give you a table, and you have to come up with the recursive form. So you have to figure out what is going on with this table. I put in 1 and I got out 5. I put in 2 and I got out 15. I put in 3 and I got out 25. So if you just examine the outputs here, it looks like I'm adding 10 every time, except I started with 5. So those are the two important things that you need to figure out in this for this problem is what did you start with and what are you doing every time? So I started with 5 and I'm adding 10 every time. So I'm going to write, since you're doing a recursive form, you need to know what a of 1 was. Well, they told you that right here in the table. A of 1 equals 5. Okay, now the tricky part is writing that second part, that recursive form. So that's going to look like this. It has to start with a of n equals, and then that previous term, a of n minus 1. So the one before it plus 10. So let me explain why I wrote that. The next term is going to equal the previous term plus 10. So look at every one of these. The next number equaled the previous output plus 10. The number 3, it equaled the previous output plus 10. The input of 4 equaled the previous output plus 10. So that's what this a of n minus 1, that just means the previous output plus 10. So that's how you would write the recursive form. And on your exam, you're just going to have to choose multiple choice. You're not actually going to have to write this. You just have to know which one is correct. So that's a little bit easier too. Okay, so what is the fifth term in a of n equals negative 3n plus 6? This one's much easier. They're telling you they want the fifth term, and all you have to do is plug in 5 for that n. So like this, a of 5 equals negative 3 times 5 plus 6. As long as you remember your order of operations, you're going to be just fine. So negative 3 times 5 is negative 15 plus 6. So a of 5 equals negative 9. So that one wasn't recursive. It didn't have like an n minus 1. It just had an n. You could just plug it in and find out. 15. What is the explicit form of this sequence? 6, 9, 12, 15. So they're giving you a bunch of outputs, and you have to figure out where they came up with that. So let me find my notes. All right, so I'm going to start by writing a to the n equals. This is what I'm trying to figure out. How can I figure out any one particular number in this sequence? Well, I know that it started with 6. The sequence started with 6. So I'm going to write 6. That's my first one. Plus, I am adding 3 to the previous number in that sequence. So let me just write this down for you. I'm going to have 3 to the n minus 1. So remember, n minus 1 shows as the previous number in the sequence. So if I wanted to find the second number in the sequence, 9, I'm just going to show you an example here. I would be looking for a of 2, and I would plug in 2 into my formula, and let's check if it works. So 2 minus 1 is 1. 1 times 3 is 3. 3 plus 6 is 9. So I get a 2 equals 9. So that is exactly what I wanted because that's the second number in my sequence. So it's very useful to understand how to use this n minus 1, meaning the previous term. What's happening to the previous term? Last one is, what if you have a graph and they want the explicit form? So you can do this a couple different ways. I'm going to actually turn this into a table, like an XY table. Remember, your x-axis is the horizontal one and your y-axis is up here. So I'm going to write down some of these ordered pairs. This first one is 0 for x and 1 for y. Then I have 1 for x and 3 for y. This ordered pair is 2, 5. So I have some numbers here that I can work with to write the explicit form. So again, I'm going to start with a to the n, or a sub n. And what I started with here, my a1, my first number in the sequence, even though there is a 0 here, with this sequence notation, they want to know what the first number was for x equals 1. That one equals 3, so I'm going to put down a 3. And then you can see that I was adding 2 every time. I'm always adding 2 to my previous number. So I'm going to have a plus 2. And remember, I'm adding 2 to the previous number. So that's where the n minus 1 comes in. N minus 1 means the previous number. So I started with 3, and I'm adding 2 to the previous number. So that's my explicit form there. So if you have any more questions on any of these problems, please ask me. You can text, IM, email, whatever is easiest for you, and I will help you. Please go through these before you do your exam. Then you'll do much better on there because you'll know what to expect.